We present SinMDM, a model that learns the internal motifs of a single motion sequence and generates motions of arbitrary length from them. Unlike images, motion data is limited, especially for animals and exotic creatures. And so from just a single dragon, our model generates a horde of diverse animations, all sharing the motion motifs of the input, even when handling very complex skeletal structures. SinMDM leverages the power of diffusion models, carefully adapting them to work with a single motion sequence. The key idea in learning from a single motion sequence is a narrow receptive field. We use the popular unit architecture, but narrow down its receptive field by decreasing the network's level of depth. Moreover, we replace the global attention layers with local ones, using state-of-the-art Q&A layers. Here, we compare animations generated by our model with those created by recent works. Ganimator uses GANs, hence experiences mode collapse and repetitive motion. GenMM is based on replications, hence it does not learn the input manifold, causing global artifacts like the missing salsa swirl, while our approach showcases natural and seamless motion. In this example, Ganimator exhibits more mode collapse, and GenMM faces challenges in preserving spatial motion boundaries. Here, we compare animations generated by our model, MDM, and a variation of MDM trained on crops of the motion. As can be seen, MDM overfits the input motion, and MDM with crops produces a motion that is discontinuous and jittery. Our model facilitates an abundance of applications with no need for retraining. One application is composition. Temporal composition means a part of the motion is given, say the beginning and the end, and the rest is to be filled in. In the shown example, given parts are shaded in gray and generated ones are full color. Note how the completed motion naturally matches the dictated parts even when they are very different from the input sequence trained on. Here is another example of temporal composition, where all horses share the same motion prefix, indicated in faded colors. The generated results, however, are unique to each horse. In the spatial case, our model is given reference body parts and generates the rest according to the motifs of the motion it has learned. In this example, the upper body reference is an exercise motion, while the network is trained on a walking motion. The composed result both exercises in the upper body part and performs the walking motion with the lower part. Similarly, we can also expand the motion sequence before its beginning and after its end. Here we show two new expansions for a given sequence. Note how the middle part, in gray, is identical in both motions. The model can also generate very long animations. Note how the input ends long before our generated sequence, which keeps on and on and on. In the demonstrated style transfer setting, the style of one motion is learned and applied to the content of another. Note how the feet are synced between the content and resulting sequences. Although trained on a single sequence, during inference, SinMDM can generate a crowd performing a variety of similar motions. Thank you for your attention.